Hello everyone and welcome to my session, What's New in Azure Machine Learning? So my name is Henk and I'm a cloud advocate at Microsoft based in the Netherlands, and my job is to make you all successful on our cloud with Azure AI. So in this session we are going to cover a few things. Azure Machine Learning is big. We only have 25 minutes, so I picked two new things I want to talk with you about. So first, for the people who don't know what Azure Machine Learning is, I'm going to explain very quickly what our offering consists of. So what is Azure Machine Learning? Then we're going to have a look at how we can use Visual Studio Code and the Azure Command Line interface, Azure CLI, to control Azure Machine Learning. And then finally, we're going to dive in online managed endpoints. So machine learning on Azure. There is a lot, like as you can see here. So if we start at the top, that are our cognitive services. So if you want to use artificial intelligence, use computer vision, use speech in your applications, and you don't want to do the AI, you can call one of our endpoints, and we will do it for you. Then you can use any tool like Jupyter Notebook, Visual Studio Code, the command line to train your own models. We support all the popular frameworks, so you can train PyTorch, TensorFlow, Scikit-learn, Onyx models, all on our cloud. And we have some services for you to make things easier, like Azure Databricks, Azure Machine Learning, and Machine Learning Virtual Machines. And we're going to talk very specifically how Azure Machine Learning can make your life a little bit easier. And finally, we have a lot of infrastructure to make your training go fast, and we can run things securely in the cloud for you. So what is Azure Machine Learning? So Azure Machine Learning is a cloud service that helps you manage the life cycle of your machine learning model. So from the data all the way up to running your models in production and getting feedback from those models. So Azure Machine Learning covers the whole day-to-day workflow, including MLOps. So what is it exactly? So it is a set of cloud services combined. It is not just one thing. It is Azure Machine Learning, it is storage, it is a key vault, it is a container registry, it's our containers. So it is a bunch of cloud services together that you can control with a Python SDK and through the Azure CLI. And today we're going to talk about how we can do that using the Azure CLI. And that set of cloud services with that tooling enables us to prepare data, train our models, track our experiments, and finally deploy our models. So Visual Studio Code and the command line interface. What does that have to do with machine learning? So I will tell you that. So the Azure Machine Learning of the Azure CLI has an extension for machine learning. And with that extension, we can control the Azure Machine Learning service. So we can run commands using a CLI command that will kick off a training, will create a data set for us, will manage and update an endpoint, can register models. Basically, everything you can do in the Azure portal, you can also do in the CLI with the ML extension. Visual Studio Code is using that extension to execute commands. So Visual Studio Code also has an extension for Azure Machine Learning. And with that extension, if you have that installed, you can connect to your workspace and get a visual representation of what is in your workspace. So you can see what type of data sets you have. You can go to your experiments, can go to the endpoints. And the cool thing is that from here, you can create configuration files that can be run using the Azure CLI. So you don't have to type the whole command. You can just create the configuration file, give it to the CLI, and run it. So how does it work? So here we have this slide. So you have your workspace, Azure Machine Learning workspace in the cloud. That is the big icon in the bottom. And Visual Studio Code understands and knows your workspace. So you see all the things. And with that knowledge, it can generate YAML files, YAML configuration files. And with those YAML configuration files, you can use the CLI to create new resources in your workspace, like kick off a training run, deploy a model, register a model, create a new data set. And when that runs, you can see that back again in Visual Studio Code. So, small recap about what we're going to do. We're going to use Visual Studio Code to show elements in your machine learning workspace. Visual Studio Code can generate configuration files for you, and Visual Studio Code uses the Azure CLI to execute these configuration files for you. And that is all very handy to separate configuration from your code that will do the actual training. So now it is time for a demo, and we're going to actually dive into the code and see how that works. So let's dive into Visual Studio Code. So here is my directory, just a directory on my local hard disk checked in to a GitHub repository where you have configuration files. And here is the Azure Machine Learning extension that can browse through my workspace. So I've already created a workspace. My workspace is called Cybertron. I have different data sets here. I have a Lego data set, version 1 and version 2. Here I have a bunch of models. It connects now to my Azure Machine Learning workspace and will get all my models. I have a lot registered, so it will generate a list soon. Here we have my endpoints, and here under we have the different types of compute that are available. So let's dive into some of these configuration files, what you can do. So I can go back to my files. And here I have create my workspace YAML file. I will tell the name, tell which location it has to be deployed, give the friendly name, can give it some tags, and I can right click on it and run. I will not do that now because we don't need a new workspace, but we can see if we can create a data set. So the data is all in here, training data, and we're going to create version 3 of it. You have to save it first. Thank you for that. And then it will, of course, first see if there is a connection to the data set, which probably is not, otherwise it would have had this connection. So what I will do is I will restart Visual Studio Code, and we will try it again. Extension is loading, checking to see if we have access to the machine learning workspace. Yes, we have access. And it should start executing the command. So here you see it is running the Azure Machine Learning or the Azure CLI command with the configuration file and as context about my subscription, resource group. So Visual Studio Code generates that Azure CLI command for me, which is very handy. So if we now go back to our Azure Machine Learning workspace, Cybertron, go to the data set, we see that it has created a new version of the data here. So this is all pretty handy and useful. But how about training a job now? So here we have a YAML file that will help me train a model. So we call it, we will log everything under the Simpsons demo experiment. You can find my training scripts in the scripts folder, in the train folder. We have a look in that folder. Here we have a Python file that actually does the training for me. So this is an example I copied from the PyTorch website, and I've added a few things. I added some references to the Azure ML Python libraries, parsing some incoming arguments, and at the bottom of the script, I am uploading the models the generated models, the created models to my experiment, tag it, and then register a model. So let's say here Azure Cloud, typing is hard, Cloud Summit, and kick off a training round because that takes a while. So it has the training scripts, and this is the command that it will execute when the training script is uploaded to the cloud. So it has train.py, it has data. I'll get back later where the data is coming from, the number of training rounds, and the model name. And this command will run in an environment. So there are two types of environments. There are environments you can create yourself, bring your own Docker container, or you can pick one of the environments that are managed by us. So I'm picking an Azure ML curated environment having PyTorch 1.7 installed on Ubuntu 18 with CUDA drivers and a GPU that is GPU enabled, and I'm picking version 3 of that container. This container is going to run on my compute cluster, Optimus Prime, which you can create also with through a YAML file. And it's going to use my input data. And this is actually pretty cool because Azure Machine Learning is or Visual Studio Code is connected to my Azure Machine Learning, it will actually autocomplete my datasets. So we are using version 3 or version 2, version 3. So this makes creating these configuration files really easy. And here we see already the output for my job that is being training in the cloud. So it is sending all the outputs back from my training script. So this will take a little while. And then eventually my model should be completed. And we should be able to see that in Azure Machine Learning itself. Hey, here we see script run 5 in experiment subs demo. It is finalizing. It is actually created now with our scripts here. And it should deliver us a model which we can find back under models with our correct tag, Conference Azure Cloud Summit. Still have to learn how to spell, but it is actually here. So here is our model. And using the CLI or the Python SDK, both have like the really big advantage that you can see how your model is being created. So this model is being created by this run. In this run, we can see which command was executed and, very important, which data set was used. So if we click here, we see the data set, we see how many files are in the data set and what the total size is. Here is this registered as the Lego data set. We have version 2 is being used. We created version 3. And we can actually explore this data set and see the images. Takes a while, but if we are patient, we will see Bart Simpson here. So these are the training images, and there are 500 of it. And that's all with some configuration file. So YAML is there for configuration, and then the Python file or wherever you want to train your model in is separated from this configuration. So now that we have a model, we probably want to deploy that model. At the moment, we can deploy models in an Azure Container Instance, in a linked Azure Kubernetes service, but now in preview is online managed endpoint. And this is a really, really cool offering because it is, like the title already tells you, it is completely managed for you. You don't have to do anything. You get automatic scaling. You can manage traffic to your different deployments. So how does it work? You create an endpoint, and in that endpoint, you can do all types of different deployments. So let's say I have model 1 and model 2. So I deploy model 1 first, route 90% of the traffic to that, and I make it run on cheap compute. It doesn't really perform, so I think let's train another model with another framework or with some different parameters, and let's run that on a GPU-enabled machine and put 10% of the traffic there. Then I add some logging, and I can really see the differences between those types of deployments. And if my deployment for model 2 is better, then I can route all the traffic to that by using the CLI or by just using the visual interface in the ml.azure.com portal. So let's see how that works. I think I've still a few minutes to show you that. Okay, so into deployment. So for the deployment, we can also use curated environments, or we can create an environment that is just very specifically for my trained model. Here, I'm creating a deployment environment called Simpson Scoring version 2, based on this, created from this Docker base image. And then I'm asking it to use this conda file to install some extra tooling for me. And that's here. So install Python 3.6, Azure ML, please, PyTorch, and Pillow. That's it. Don't install anything more, just install that. Then I can start creating an endpoint. And when you create an endpoint, you also specify your first deployment in it. So this endpoint is called Simpsons Demo. It is an online endpoint. And I'm saying just add some authentication for me. So this I don't have to handle in my code. This managed endpoint handles authentication for me. Scale all the traffic to the first, to 100% of the traffic to the deployment called V0, V01. And here is the deployment. Enable application insights for me, out of the box, application insights, so you can track your performance of your container. And then use upload all the code that is in scripts score, and use this scoring script because it will run into in a server, and it needs like a little bit of code where you tell what it should do to load your model and how to run data through your model to get a prediction. So this is an init method, and this loads your model. And then there is this run method, and that will parse the incoming JSON, downloads the image, does pre-processing over the image so that it is in the right tensor, and then it will run it through the model, and it will return the prediction as a JSON to us. So that is that. So score.py. Run this in the Azure Machine Learning Simpsons v4 version 2 environment. So this is an environment I have created. Use some compute, use the standard F4S v2 virtual machines. You can say also the standard NC6 machines if you want to have a GPU. And then you can define how you want this deployment to scale for you. Do you want to have it manually, like me? Or do you want to have it automatically and say max 10 instances? The minimum is 1, and now spin up 5, please. So you can say those kind of things here. So then you have one deployment up and running, and you can add another deployment. So this was version 1 of the model, and now we're going to add version 2 of the model. Same thing, application insight, same instance type, same scaling, but just a different type of the model, of different version of the model. Version 1 I trained only for 2 rounds, and the other one I trained for 12 rounds. So this should be a very distinct in the outcome. If I send one image to one endpoint and the other image to another endpoint, there should be some difference visible in that. And then I can say Azure ML, update the endpoint with Simpsons 5 and scale the traffic 50-50. So this I've done. It takes around 10 minutes for the deployment to be done at the moment. So we're not going to wait for that. So here we're going to look at the deployed endpoint, and we will see Simpson's demo here. We have two deployments, version 1 and version 2. We had 50% of the traffic. Here we see which model is actually running in there, environments. And here we see version 2 is running in there. We can have a look at the deployment logs for if anything goes wrong. Can go to the metrics and to the deployment back. Here is how we can actually consume it. So there's a URL. There are some keys here, some sample code. So let's see what happens if we send an image from what we're sending to Homer Simpson to that endpoint. No, that's not what I wanted to click on. I wanted to click here, send request. So we've sent a request and we see that we hit Azure ML model deployment version 2 and the score is 95% for Homer Simpson. Now we've sent it to version 1 and it is 85. So if we keep doing that, we will see that it's all different requests that will swap between endpoint 1 and 2. So that, in very short, are two things I wanted to talk to you about what is new with Azure Machine Learning. So if you want to check out my demo code, you can go to ak.ms, AML, Azure Machine Learning, demo VS Code. Or if you want to read more documentation and see more examples than my quick 20 minutes about the technology, you can go to ak.ms/AML VS Code or ak.ms AML/OMA online managed endpoints and learn more on Microsoft Docs.